All right. In this explainer, we're going to meet two of the most reactive and, believe it or not, surprisingly colorful families on the entire periodic table. So let's just dive right in. Okay, first up, a little puzzle for you. What on earth could possibly connect the brilliant colors of a fireworks show, the regular old salt on your kitchen table, and the electrical signals that are firing inside your brain at this very moment? I know, it sounds like a totally random collection of things, but the answer is actually pretty elegant. And that answer, it lies with a group of elements called the s block. Now, the technical definition is that their last electron enters something called the s orbital. But what's really important for us is that this one little detail gives them a very distinct personality, and it makes them the stars of our story today. So these s-block elements are organized into two groups, and they live right next door to each other on the periodic table. The best way to think about them is as two closely related but very different families, Group 1 and Group 2. So let's meet Group 1, the alkali metals. This family has some real famous members like lithium and sodium. And their defining trait? Well, they are the ultimate eager givers of the chemical world. And you're about to see exactly what that means. And right next door, you'll find their neighbors, the alkaline earth metals of Group 2. This family includes elements you've definitely heard of, like magnesium and calcium. Now, if Group 1 are the eager givers, think of this group as the slightly less eager givers. They're still pretty generous, just, a little more reserved about it. So what's the big difference? It all comes down to this one simple thing. The alkali metals in Group 1 have one single, lonely electron on their outer shell that they are desperate to give away. It's how they find stability. Their neighbors in Group 2, they have two. And this simple fact, one electron versus two, it literally defines their entire character. So, let's put these families head to head. You're about to see how that one little electron difference causes two completely different chemical personalities to emerge. Okay, this is where it all clicks. Because Group 1 metals only need to get rid of one electron, it takes very little energy to do so. That's what low ionization enthalpy means. This also makes their atoms pretty big, and the bonds holding them together are so weak that you can literally cut pure sodium with a butter knife. It's that soft. Group 2, on the other hand, has to give up two electrons, so it holds on a little tighter, which makes those metals smaller and a whole lot harder. Now, within the Group 1 family, there's a really clear trend. As you go down the list, from lithium all the way to cesium, the atoms get bigger and bigger. That single outer electron gets further and further from the center, which makes it even easier to give away. So what does that mean? It means they get more and more reactive as you go down. Cesium is the most eager of them all. But of course, just like in any family, the firstborns can be a little different. Lithium from Group 1 and beryllium from Group 2 are so tiny that they often behave differently from the rest of their relatives. They kind of break the family rules. All right, now for the fun part. Let's see how all of this chemistry leads to one of their most spectacular properties, the ability to put on a brilliant light show. Hey, remember our opening question about fireworks? Well, we're about to get our answer. The secret is that when you heat these S-block metals, they put on their own personal and very colorful light show. This is their unique chemical fingerprint in action. It's amazing. When you heat them, each of the alkali metals emits a signature color. Lithium glows this deep carmine red. Sodium gives off that unmistakable golden yellow you see in old streetlights. And cesium? Cesium burns a beautiful sky blue. But what about their neighbors in Group 2? Well, interestingly, the first two members, beryllium and magnesium, are kind of camera shy. Their electrons are held on so tightly that the energy from a simple flame just isn't enough to get them excited. So they don't produce any color at all. This extreme reactivity isn't just for show. It leads to some incredible real-world applications. Take cesium again. Because it gives up its electron with almost no effort, that's that super low ionization enthalpy we talked about, it's perfect for things called photoelectric cells. You know, the tech that powers everything from automatic doors to solar panels. So, okay, these elements are reactive, they're colorful, but why should you really care? Well, it turns out they are fundamental building blocks for both our industrial world and our own bodies. On an industrial scale, these elements are everywhere. Sodium hydroxide, a super important chemical, is made from something as simple as salt water. And the cement that builds our cities, yep, that's thanks to calcium compounds like lime and gypsum.
But let's get even more personal, because it turns out that just 4 ions from these 2 families are absolutely 100% essential for life. Sodium, potassium, magnesium, and calcium. These 4 are responsible for maintaining the delicate electrical balance inside our cells, and crucially, they transmit our nerve impulses. So yeah, the answer to our puzzle, the very signals firing in your brain right now, they depend completely on these S-block elements. So from fireworks and cement to the very thoughts inside your head, these 2 neighboring families have an absolutely incredible impact on everything. It just goes to show you, the periodic table isn't just some chart in a textbook. It's a map of the elements that build our entire world. Makes you wonder, what other secrets is it hiding in plain sight?